So let's talk about how we can take the derivative for the function x to the sine x power. This is easy, right? Because the power is sine x, just put the power to the front and then minus 1 and then say that's sine x in the front times this x and then raised to the power of sine x minus 1, right? No, this is not correct. We cannot do the power rule right here because the power rule is only for when the base is x and the exponent is a number such as 5 or 2 or 17. Then you can bring the number to the front and then minus 1 and you get 5x to the fourth power. Sin x is a function, so it does not follow the power rule. Okay, so in this case, what do we do though? Don't worry, I'll help you understand this and I'll show you guys two ways to take the derivative of this function. First thing, whenever we have a function for the base, here we have x, which is a function. And if the exponent here is also a function, here we have sin x. Then we can do the following. Starting by let y equal to this thing. So x raised to the sin x power. And then we are going to take the natural log to both sides. Because this way, by the log property, we can bring the power to the front and make sure to not minus 1 because here we are not doing the derivative. This is just the natural log property from algebra. So we can get an equation, ln y is equal to sin x times ln x. So as you can see, we don't have a function to a function power anymore. And this is just a product rule case. But the downside for doing this is that, the y is no longer isolated, but it's okay because it's an easy fix, because we can do implicit differentiation. So the whole process right here, when we take the natural log to both sides and then do implicit differentiation, this is called the logarithmic differentiation. Fancy term, isn't it? But anyways, let's see how we can do it. Let's put on d dx to show that we are going to take the derivative of this with respect to x. Now, the derivative of ln y is just 1 over whatever the inside is, which is the y. And then remember to do the chain rule. Multiply by the derivative y, which in this case is just dy dx. And then on the right hand side, it's a product rule. So I will keep the first function, which is sin x, and then we multiply by the derivative of the second, which is 1 over x. And then we add the second function times the derivative of the first. The derivative of sin x is cosine x, and that's what you will have to remember. Cool. Now, we want to get the y by itself, then to do so, we can just multiply both sides by y like this, and make sure it's the entire right hand side, so that this and that cancel, and we can get dy dx that's equal to y times this. But for the y though, if you want to just write this down for the answer, originally there's no y, right? But don't worry, because y is just the same as x to the sin x power. That's what the y is. So for this y, let's go ahead and put that down. X times, raised to the power of sin x power. And then for the rest, probably we can just write this as sin x over x. And then this right here, just keep it. We can put it as ln x times cosine x. There's nothing much that we can do. And this right here will be the answer for that. Okay, so that's the first way. And now for the people who didn't like how we call this to be y and then do logarithmic differentiation, you can do it directly. Let me show you. Again, the trouble for this is we have a function to a function power. We don't like that. We like to have the base being e, about 2.7, but let's go ahead and use the e number. So this is how we're going to do it. Look at the base e, the base x, but we really want to have e. That's why I misstated earlier. Here's the deal. Note, x, I really want to see the e, but this is not equal to this. But don't worry, e and ln cancel, but you have to put the ln in the power, and then the x right here. E and ln cancel, you get the x back. So we are going to purposely write x as e to the ln x power. So here we are differentiating, parentheses, e to the ln x power, and then raised to the sine x power like that. Now we have a power to a power. We can multiply these two exponents. So this is to take the derivative of e, and then let me write down ln x first, times sine x. Now we can get to work. Firstly, when we differentiate e to the something, this right here stays. I will just keep it as how it is. E to the ln x times sine x. And then we will have to do the chain rule. So I'll open the parentheses for the result of this differentiation. Here though, we will have to do the product rule. I'm going to keep the first function, and then we multiply by the derivative of the second, and then we add the second function times the derivative of the first, which is 1 over x. Just like this. Now, have a look. What's this? Which is just that. Which is just this. Which is just the original, right? So all the way in the front, we have just x raised to the sine x power. And then the rest, really, it's the same as what we got earlier. It's just the order that's different because how we write this right here. Not a big deal because the order of addition doesn't matter. So that's it.